Alright, so sorry guys for not being here to do our officially last lecture. And actually, let's just jump into today's topic. So today we're gonna quickly finish up what we left last time, which is about actor model. And it's just gonna be a brief discussion over the actor model. So there are still a lot of things, happening behind the scene, and we don't really have time to talk about this in this quarter. But I do highly encourage you to go over on your own when if you are actually want to, further explore the iOS development world. Okay, actor model is really important, and there's a lot of things we will not be able to cover. Okay, now let's pick up from where we left last time. Okay, so last time we mentioned that all the calls inside an actor are always synchronized, okay, or always executed synchronously. Okay, so let's take a look at example to see what I mean by this one. Okay, so let's navigate to our Xcode. So just kind of recap to take a look at this actor counter, this actor counter. What did we define before? Okay, and we also have a class which is gonna use this counter. Okay, and also we have this task group to initiate concurrent tasks. Okay, which gonna call the increment on the counter. Okay, on this counter actually. Okay, so by using the actor, we already solved the concurrency issue, right? Now, let's take a look at what I mean by, all the internal call are synchronized. So take a look at this one. Okay, now I have extension, okay, extended on the counter, and I define a function named as increment2. Okay, and inside this increment2, I essentially just call the increment, which already defined in the previous class, just increment by 1. Okay, increment the value to the target value. Okay, just repeatedly call this increment multiple times. It's quite straightforward. Okay, by using a for loop. Now here we go. We use the increment. Okay, and by using this increment, I don't need to put the await keyword before. Okay, because by default, all the function call inside that actor are by default are synchronously executed. Okay, so the Swift knows the context, so you don't need to put the await or async before that function call if you are calling the function right inside that other function defined in the actor. Okay, now go back to the slides and again take a look at this description. So it says calls inside an actor are always synchronized. Okay, is that clear? And there's a assert statement. Well, this is again, if you're not familiar with Swift or any other language before, that might be a new thing to you. So assert is a special function, which in this case essentially says the target value should be equal to the self.value after I repeatedly execute this increment function. Okay, if it's not, okay, if this one returns false, it's just gonna crash your app. Okay, so assert can be really useful when you want to test your program, because sometimes well, when you're testing your program, you want to spot the bug, right? So you want your app actually get crashed, so you can pinpoint the problem. Okay, so that's how you use the assert. Okay, now there's one more thing I want to mention is this one, this yellow one. It says result of call to increment is unused. Okay, so why is that? So let's go back to take a look at this increment function. Okay, where we define this function. I said function increment, and this function takes nothing, but it returns an integer. Okay, so it returns something. But here, when we use this function call, I don't care about what kind of thing it returns, right? I just call that. Okay, so it gives the compiler, the Swift compiler gives me an error. No, it's not an error, it's a warning. It says result of call to increment is unused. Okay, so there's several ways to silence this thing. First thing you can do is do something like this. Okay, you can see I call the increment function and assign the return value to something I don't care. Okay, with this underscore. Okay, this underscore, we already mentioned this before, briefly mentioned this before. Essentially, it means I don't care. Okay, but there's a more elegant solution. Like if in this case, I already know that usually, like for the most of the time, user maybe don't want to use the return value here. So I can go back to the implementation of this function, and before the func keyword, I can say at discardable result. Okay, it means the result usually doesn't matter. Okay, but if you want the return value, okay, you can use that. But usually, if you don't want that, it's okay. I'm gonna silence that warning. Okay, that's how I use the increment function without having any warnings. Okay. Now let's go back to our slides again and take a look at the next one. Okay, and you can explicitly break the isolation. Okay, what I mean by isolation, it means the actor actually isolate every operations when you access the internal, when you are calling the internal functions or accessing the internal values. Okay, it has the isolation. Okay, so but you can also you can explicitly break the isolation by using the keyword called non-isolated. Okay, let's take a look at the example here. Okay, so again, I can extend on the counter. Of course, you can also define this function right inside the actor. It's totally valid. Okay, just for clarity, I use the extension here, and I define the function name as dummy print. Okay, this function print something. Okay, and you can see in this function, I don't really use any internal value, any local value defined in the actor, and I don't call any like internal function defined in the actor. Okay, in that case, it's totally safe for the caller to call this one in a non-isolated way. Which means calling this function without explicitly using the await keyword. Okay, so I can use this keyword says non-isolated. Okay, by doing so, when I call this function, it just says counter.dummy print. Okay, you can see there's no more await keyword before that. Okay. Now let's move to the next example. Okay, so this time, well, it's still the dummy print, and I still want to mark that as non-isolated. But this time, I just gonna print the value, and the value, which is a local variable, I declared in the actor counter. Okay, but this time, the compiler just gonna give you some errors. Okay, it says actor isolated property value cannot be referenced from a non-isolated context. Okay, in this case, Swift compiler can be smart enough to spot the problem inside your code. It says you are referencing some non-isolated, you are referencing some, well, supposed to be isolated variable, okay, but you mark that as non-isolated, which is not really a safe operation and it's not allowed. Okay, so you're gonna give you some error, and well, you won't be able to compile your project in this case. Now, the non-isolated keyword has lots of other use cases. Okay, and sometimes you might explicitly want to use this non-isolated keyword. Okay, let's take a look at another example where we actually need the non-isolated keyword. Okay, you can see this one is what we defined before. Okay, what I showed you guys before by using non-isolated. Okay, now this time let's again create an extension. Okay, and again I'm gonna extend on the counter, and this time I want to implement the two protocol for this counter. First one is gonna be equitable. Okay, when we want to make the counter a actor, a class, or enum to conform to the equitable, okay, essentially we're gonna need to provide a function. It's a static function, okay? And the function name is equal. Okay, essentially just provide a method to let the this actor know how to compare between different counters. Okay, in this case, I can just say, okay, as you can see, when we define this one, we already have the ID. Okay, so we can utilize this ID. I can just say right hand side. Sorry, I'm gonna move back to this one. I can say right hand side dot ID equal right hand side dot ID. Sorry, left hand side ID equal right hand side ID, and of course, essentially I get rid of the return keyword here. Okay, so it turns a Boolean expression, evaluates to Boolean. Okay, I think it's pretty straightforward, huh? Now we have implemented the equitable protocol. So how about we want to implement another protocol which called hashable. Okay, for anything to be conformed to hashable, again it has to provide some functions. Okay, let me see. Okay, so the auto-completion didn't give me any help, but let me tell you. So for anything to be conformed to hashable, it has to provide a function named hash into. Okay, and in this case, I can just say hasher dot combine ID. Okay, I mean this function is pretty new for you, I believe, and you can see this hasher. The type is a hasher type. Okay, it's marked as in and out. It's a pretty new concept for you, but it's okay to just leave it here. So you just know the high level concept for this one. So essentially, I use a hasher function, okay, and calculate the hash value based on the ID. Okay, this ID refer to the local variable, the local property ID. Okay, so I use the hasher function, okay, and calculate the hash value based on such ID. Okay, but there's some problem to implement this thing. You can already see there's a warning. It says actor isolated instance method blah 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 cannot be used to satisfy a protocol requirement. Okay, so the thing is this hasher, which is marked as in and out. Okay, this thing, the actor system cannot guarantee this hasher instance can be thread safe. Okay, it's not isolated. Okay, in this case, this function has to be implemented in a non-isolated way. In this case, you're gonna have to provide a non-isolated function to explicit about the non-isolated case. Okay, that's how you implement this thing. Now let's go back to the slide and take a look. And yeah, that's another example I show you guys where we might want to use these non-isolated keyword. Okay, now let's jump over to what we have discussed. Okay, we just scratched the surface of the actor system, and there's still lots of things you may want to know if you really want to use this actor to achieve the concurrency. But anyway, we're just gonna jump to another topic, which is gonna be some special actors already exist in our system already exist when our app is running. Okay, and the main actor is one of that special actor. Okay, the main actor will execute all the tasks on the main thread, just like the main dispatch queue. Okay, they have kind of similar purpose. Okay, they're both serialized everything. Okay, and they both execute tasks on the main thread. Now let's take a look at some example to show you how to ensure the function can be run on the will be run on the main thread. Okay, you can do several ways. So first thing you can do is mark the function with @main actor. Okay, in this case, when you call that function, you can see await. Okay, so this @main actor actually internally transform this normal function into a async await function. Okay, and well, the other approach you can, you can choose is actually call this in await main actor.run. Okay, you already see both cases before when we talking about the web URL. Okay. Or there's another approach. You can also mark the entire class with these @main actor. Okay, by doing so, essentially it kind of serialize all these operations in that function. In that class, and all this function will be assured to run on the main thread, which will be run on the main actor, and main actor gonna run things on the main thread. Okay. However, in this case, this non-isolated fetch data function can be an exception. So in this UI helper, when we call the update UI or update image function, both functions gonna be run on the main thread because they should be run on the main actor. However, when we run this fetch data, since it's non-isolated, okay, it can be dispatched to some other threads behind the scene instead of running on the main actor, because it's non-isolated. Okay, that's how you use this main actor. Now, as I mentioned before, there are lots of things we don't really have time to cover. So, for example, there's a very important concept, it's @sendable, okay, and also sendable protocol behind the thing. They are quite essential in the Swift concurrency, and this is kind of support the Swift compiler to check whether the data or the closure passed in can be safe from data race. Okay, and they're quite important. And also you have seen before, which called async sequence. Okay, and you might want to know something called async string, which is kind of how you implement the async sequence thing. Okay, and also you want to know about actor reentrancy. So I briefly mentioned that in the previous lectures. So when it comes to the dispatch queue, everything has to be dispatched in the FIFO order. So when there is some higher priority item just get placed in the dispatch queue, it won't be able to reschedule the higher priority item maybe to the front of this dispatch queue. It's not gonna happen. Okay, but the actor has the reentrancy, so therefore the reentrancy is a really complicated thing. Just what I'm saying right now is just some kind of use case for the reentrancy. So the actor can actually solve the priority inversion problem and kind of prioritize things for you. Okay, and also continuation is another big concept in the Swift concurrency. Everything inside the Swift concurrency is actually implemented in a small unit called continuation. Okay, when we talk about the dispatch queue, you can see the concurrency unit is going to be thread. Okay, so the dispatch queue create multiple thread and actually schedule things to multiple different threads and switch threads back and forth. Okay, that's how dispatch queue manage all these tasks. But in the Swift concurrency, it has the continuation thing. Okay, and actually run on one thread. It's not really 100% accurate. It can also create multiple thread, but the thing is, you can have multiple much smaller unit inside one thread. Okay, which can also reduce lots of context switch cost. Okay, which can be a big improvement over the Grand Central Dispatch. Okay, and also you may want to know how to bridge Swift concurrency and GCD. Okay, and also you may want to know the scheduling mechanism behind behind the scene, which is quite important to actually fully understand this the whole picture. Okay. Now that's all for the last lecture. Now let's just jump into today's topic. Okay, so today we're gonna actually briefly discuss about gestures, GeometryReader, and preference key. Okay, so the gesture is quite straightforward. It's gestures. Okay, and the GeometryReader is something you may want to use to get the size of the parent view. Okay, we're gonna see some examples very soon. Okay, and the last thing is preference key. Preference key is a tool to help you to pass data from the child view to the parent view. Okay, we want to pass some data from the parent view to the child view. You already have some tool. For example, we have talked about the environment object, right? We can also use, like use the just pass the data, to the child view, so child view can have the access to data from the parent view. Okay, it's quite intuitive way. However, you may sometimes want to pass the data from the children view to the parent view, and that's in that case you want to use the preference key. Okay, and also we're gonna kind of conclude to our class for this quarter to introduce give you an overview of the entire picture of Swift UI world, the Swift world, the iOS development world, of all the different framework out there provided by Apples. Okay, now let's jump directly into the gesture part. Okay, so let's take a look at gesture. Now I created entirely new project, and it's gonna be pushed to the our course GitHub repository. Okay, so I already have our project open, and let's go to this file and gesture panel. Okay, and you can see in this one, let me actually resume this thing. Okay, in this one you can see we have a circle which we define here. Okay, and then we have a local variable marked as state. It says is tabbed. Okay, we're gonna use this variable later. Okay, right now the initial value is false. Okay, so the circle by default, okay, is red. When this is tabbed is toggled to true, it's gonna be turns to green. Okay, well, it's quite familiar, quite straightforward syntax here. And also I had apply a frame here. Okay, it has a width and height both of 100. And in the body, actually, I just display the circle. That's pretty straightforward. Okay, now let's first take a look at the the tap gesture. Okay, the tap gesture, actually we have been using that for quite a long time. So we have been using this thing called on tap gesture. Okay, and when some tap happens, I want to trigger this is tapped and toggle this thing. Okay, you can see when we tap this thing, the color actually changes. Okay, this is our kind of really handy way to apply this tap gesture. Okay, now let me show you a more generic way. Okay, a more say advanced, maybe not, a generic way to apply some gestures instead of just tap gesture. So for every view, it has some a view modifier named as gesture, and it takes a gesture. Okay, now let's declare this view modifier here. And let's see, create something called tap gesture. Okay, the tap gesture is struct. Okay, and I create a tap gesture instance here. Okay, and on the instance, it has a function called unended. Okay, and the unended can take another action here. So actually, let me first transfer this into a trailing closure. Okay, you can see this is a form. So the unended is essentially, I mean, the thing for the untapped gesture, the closure the untapped gesture view modifier takes. Okay, essentially when the tap gesture happens and it's ended, what kind of thing you want to do. So in this case, again, I want to toggle this thing. Okay, you can take a look at this thing. Well, I mean, it's essentially the same thing, right? Now, usually in your program, when you actually develop a program, you may want to extract this gesture out. Okay, so you can create some computer variable. Let's say tap gesture, just to make the code looks more cleaner. Okay, way more cleaner. Okay, so I can say some gesture. Okay, gesture is a protocol. Okay, it's kind of like view. Okay, when you declare this thing, you have to put some before. Okay, and now let's say tap gesture and put this thing here, and when we use this tap gesture here. Okay, now you can see we kind of extract this tap gesture out. Okay, now you can resume this thing and take a look at the behavior, exactly the same. Okay, now let me show you something fancier. Okay, so the tap gesture actually can take some arguments. It says count. Okay, so by doing count2, essentially means when we double click on this thing, now it's gonna rest this tap gesture. So when I click once, sorry, actually I'm gonna resume this thing. So when I click once, just one time, click one time, there's no change. Okay, you have to double click on this thing. Okay, now you can trigger this unended. Okay, you can also go 3, which means triple tap. I mean, you can go whatever number you want. Okay, I think that's pretty clear so far. Now, actually, let me show you how to apply a long pressing gesture. Okay, now let's first uncomment out this thing. It says at gesture state, and it's something called is long pressing. Okay, and it's a boolean. By default, it's a false. Okay, I'm gonna explain this gesture state property wrapper later. So first, let's create something called the maybe long press gesture. Okay, again, some gesture, and I'm gonna say long press gesture. This thing, okay, here. Okay, and it says let me show you something new. Okay, on a long pressing gesture, I can do something called updating. Okay, so the first argument the updating takes is a binding. Okay, a binding to something marked as gesture state. In this case, I'm gonna put the binding of is long pressing variable. Okay, now let's take a look at this body thing. Okay, now let me actually expand this thing a little bit. So this closure actually passed in. There are 3 arguments passed in. Okay, so first one, it's a boolean, and we usually name as value, and the second one is named as state, and third one we can ignore that right now. Okay, so let me actually explain these 3 values here. Okay, so this first value is some value returned from this gesture. Okay, in this case, this value is just gonna be whether the long pressing is happening or not. Okay, the state, as you may see before, is marked as in and out. Okay, it's an in-out keyword, an in-out variable. In this case, this thing actually is referencing this one. Okay, they are exactly the same thing. Okay, so in this case, I can just say the state equals the value. Okay, by doing so, when the long press gesture has something to update, it's just gonna update the state. with the value. Okay, and the state is this one, is this long, long pressing variable. I mean, there is some actually subtle difference here, but you can think of that in this way right now. Okay, so this state means this one. Okay, they are exactly the same thing passed by reference. Okay, so let's comment out this thing. Okay, so I can have a nice text to display whether this long press gesture is happening. Okay, now I'm ready. Let me try to long press this thing. Okay, oh, sorry, I forgot to replace this tap gesture with long press gesture. Okay, now I'm ready to long press. Ooh, you can see this flag turns to true and then goes back to false. So what's happening here? So long press gesture actually gonna finish its how am I supposed to put that? So long press gesture gonna mark as finished when after a certain period of time. Okay, in this case it has some default value for the period of time, which I believe is half a second. Okay, so after half the second, okay, you're gonna mark this long gesture as finished. Okay, in this case the value passed into this one gonna be false. Okay, actually you can just adjust this behavior by setting the minimum duration. Minimum, did I put that right? Minimum duration here. Okay, maybe I can say 2 seconds. Okay, now resume this one and do a long press. You can see this time I trigger this for 2 seconds, and after 2 seconds, the state just gonna be assigned to false. Okay, because it's gonna be marked as finished. Now, of course, sometimes you may want to do do a long press for infinite time because you just want the long press state here. Okay, you can do that to put a .infinite. Okay, for the minimum duration. Let's resume this thing. Now you can see when I do a long press here. Okay, sorry, I moved the mouse. So I want to do a long press here. You can see this state still be true. Okay, now when I move this in a little bit, you can see this long press gesture got cancelled again. Okay, of course you can also adjust this behavior by setting maximum distance. Okay, you can explore these arguments on your own. Now that's long press gesture. Okay. Now let me see. One thing I might have to mention here is, what if I want to apply multiple gesture here? Okay, for example, I can apply 2 gestures. First gesture is gonna be the tap gesture. Okay, second one is gonna be a long press gesture. Okay, what kind of thing gonna happen in this case? Let's take a look. So this tap gesture gonna be triggered by double tap. Okay, so let me try to double tap this thing, and you can see it happens. Right, it triggered correctly. Okay, now what if I want to do a long press gesture in this case? So let me try to do that. Okay, I'm starting the long pressing. You can see it turns true. Okay, you can see when I apply multiple gestures, they can kind of combine. Okay. Okay, now the gesture actually has several different ways to combine their each other. Okay, there are there are 3 approach. First one is called exclusively. By doing exclusively, only one gesture. If there are multiple gestures applied to that view, only one gesture gonna be recognized. Okay, and of course you can also adjust the priority of gesture by applying something called higher priority gesture. Okay, but you're gonna explore that on your own. Okay. And you can also apply some simultaneous gesture, okay, which means this view can recognize multiple gesture at the same time. And also you can do something like what's that called? Let me see. This is defined on the gesture. Should be a sequenced gesture, okay? So something called sequenced. So in that case, you can define a sequenced gesture. For example, you want to maybe let user to drag the view, but user have to do a long press before the dragging. Okay, therefore you can use this .sequenced. Okay, so just to give you guys a higher conceptual view of this entire thing, but you have to explore this thing on your own because we don't really have enough time. Okay. Now let's comment out both things, and let me show you guys another gesture called drag gesture. Okay, let's say drag gesture again. It's gonna be some gesture. Okay, and this time I'm gonna declare this gesture by doing this drag gesture. Okay, again we're gonna use this upper dating. Okay. Now let's comment on this thing. Okay, again it's marked as state gesture state. Okay, it's named as dragged translation. Okay, it's a CG size and by default it's 0. Okay, now I'm gonna take a binding from this drag translation. Okay, and inside this body, again, I'm gonna give the name for these 3 arguments: value, state, and the next one is gonna transaction. Okay, we're not really gonna talk about this transaction in this case because well, it's kind of complicated. But the transaction actually can help you to define some animation. Okay, if you want to know about that. Now, when we drag this thing, the value is gonna be the drag some data returned by the drag gesture. Okay, so actually we can take a look at the value. Okay, and take a look at some properties it has. Okay, so like it has translation, it has predict and translation, it has time, it has predict and location, all kind of thing. And then we're gonna use this one called translation. Okay, and then we're gonna assign this translation to the state. And this state actually referencing this one, this drag translation. They're exactly the same argument, same variable. Okay, by doing so, we're gonna constantly update this drag translation. Now, let's go back to the circle. So what if I want to drag this circle around? Okay, how can I do that? So first thing I'm gonna show you guys, which is might be a new thing for you guys, is something called as offset. Okay, and the offset actually, as the name suggested, can offset the view. And the reason I didn't talk about offset before, because the offset usually just gonna only be used when you want to do some animation or gesture. Okay, when you actually want to lay out things, you don't want to use this offset. Okay, now we already have a offset called drag the translation. Okay, it's gonna be indicate how many distance we dragged this item. Okay, so we're gonna use this thing, drag the translation. Of course, you can also apply offset with something x and y. And yeah, that's another function call you can use. So in this case, we're just gonna use this offset. Okay, and then this time we're gonna apply this gesture, gonna be the drag gesture. Okay, that's all for this one, for this drag gesture. Let's take a look at this thing. So I click on this thing and trying to drag this thing. Okay, is that clear? Now, when I release that, you can see it snaps back. Okay, it kind of reset this drag this translation to the initial value. Okay, this is magic actually done by this gesture state. Okay, the gesture state actually is not really something special. It only has one additional feature, is when you finish a gesture, you're gonna step back to the initial value, and that's all. Okay. So this is same case for this long pressing. Okay, when the long pressing finishes, you're gonna return back to the initial value. In this case, gonna be the false. Okay, if you set the initial value to true, you're gonna be returned back to the true when the long press finished. Okay. Now, let's take a look at how to apply an animation here. Now, when you just snap back, it kind of, you snap back. Sometimes you want some animation. Okay, so you can do the animation by say .animate. Maybe go with linear, and I'm gonna say drag the translation. Okay, so when the drag translation changes, I want to animate this thing. So take a look at this thing. When I release the mouse, oh, you animate back. Okay, this is neat. However, the thing is, when I drag this thing, when I move this mouse a little bit quicker, okay, you can see it does not really follow the mouse. The reason is, when we actually move this mouse, you also apply an animation, and it's a linear animation. Okay, now let's actually change this linear with a duration. Maybe go with 5. Now, again, back to our preview and trying to drag this thing. Okay, you can see this behavior way more, prominent. Okay, as affected by the animation. Therefore, sometimes you don't want that, because when user drag this thing, you want to actually stick with the finger, and when the user let it go, it animate the animation when it goes back. How to achieve that? In this case, we have to take control over the entire update process during this drag gesture. Therefore, we might not want to this one. We might not want to use updating thing. Okay, we can get rid of this thing. Let's create a new thing. This time it's gonna be a state. Okay, we don't want a gesture state to manage the value for us. Okay, I just want a state. You can say state var drag translation. You can comment this out. Again, it's gonna be sage size of 0 as the initial value. Okay, so without using this .update thing, instead we can use two functions. First is unchanged, and second one unended. Okay, these two functions can give you more granular control over this entire value updating process. Okay, so this unchanged gonna be triggered when some data changes. For example, when user actually drag this thing out of the original place, okay, you're gonna be triggered. Okay, and this value is gonna be actually quite similar, actually exactly same as this value. Okay, so in this case, again, I'm gonna assign this data, this translation data, to this drag translation. Okay, and so what about the ended? Okay, so when ended, again, you're gonna assign me a value. Okay. In this case, I don't really use this value. So when the drag gesture ended, I just gonna, simply reset this drag translation to sage size 0. Here we go. Now let's try to run this thing and take a look at this behavior. Okay, run this thing, and okay, the dragging is working. Okay, now how about just release the drag? Okay, you can see this thing snaps back, okay, just as what we have before. Okay, now since we have more, sort of, gain more control over the entire process, I can be explicit about this snapback behavior. I can say with animation. Okay, so when the drag gesture ended, I can snap back with an animation. Okay, sorry, I have to resume this one more time. So you can see when I drag this thing, it goes with my mouse. Okay, actually goes with my finger. Now when I release this thing, it snaps back with a linear, which is gonna be default animation. Okay, that's how you use this unchanged and unended gesture. Okay, and also you can have some other gesture. For example, like, let me see. You can also use other gesture like magnification gesture. Okay, let me comment out this thing, magnification scale. Okay, I have this one as a siege float. Okay, and the initial value is 1. Okay, so now I want to apply a magnification gesture to actually zoom in or zoom out this circle thing. Okay, so actually let's first define magnification. I'm gonna call it as mag gesture. So it's gonna be some gesture, and it has a struct called magnification gesture. Okay, and also it has a function called updating. Okay, again I'm gonna take a binding from this, what's that called, magnification scale. Okay, and for this body I'm gonna say again value, state, and ignore this one. So I'm gonna assign this value directly to the state, and this value is gonna be the scale you actually zoom in or zoom out. Okay, now let's apply this thing to the circle. So how we actually zoom in or zoom out one thing. Okay, first comment these two line out. We can apply a thing called scale effect, which you have already seen before, right? So in this scale effect, I'm gonna use this magnification scale. Okay, and I'm gonna apply this gesture called what's that called? It's mag gesture. Okay, let's resume this thing. So how are we supposed to zoom in or zoom out in the simulator? We can hold in the let me first see. We can hold in the option key in your computer. Okay, and you can see these two kind of finger pops up. Okay, this can help you to zoom in or zoom out. Okay, so now you click and drag. You can see this thing zooms out. Sorry, zooms in. Okay, and when you release the finger, it goes back. Okay, that's a behavior provided by the add just state. Okay, just reiterate this thing. Of course, you can also zoom out. Zoom out. Yeah, of course. Yeah, sorry, zoom out and zoom in, zoom out. Okay, that's how I use gesture. Okay, so we're just gonna stop right here and get over this gesture things. Actually, there are also lots of complicated things how to sequentially chain the gestures. There's also an option, and sometimes it can be really helpful and really important thing when it comes to certain things. But anyway, we're gonna move to next thing called GeometryReader. Okay. Let's see. So I have some skeleton code here. So I have a GeometryReader demo. Okay, and I also have an inner view, essentially just a color. Okay, and this GeometryReader view, it contains an inner view, and this inner view has a border. Okay, well, first it defines with a frame as both has both width as 100 and height as 100. Okay, and it has a border. It's a greenish border, and you can see here greenish border. Okay, now this is kind of standard thing you usually do in SwiftUI, right? But what if I ask So I want this red, this color, always be only half of this parent view. Always be half of this parent view. Okay, for example, right now I have this frame defined by 100 and 100. Okay, so what if I define maybe 200 and 200? Okay, I want this color have a width and height only half than this container has. Only half the width and half the height of this container view. Okay, in this case I want it has a both width and height as 100 if this one is going to be 200. Okay, so how we can get this information about this parent view? Okay, we can use something called GeometryReader. Okay, and GeometryReader takes a closure which is gonna be passed in a something called GeometryReader proxy. Okay, in this case I just gonna name that as proxy. You may sometimes sometimes you may want to find a better name for this one, but right now I just go with proxy. Okay, and proxy have some interesting thing. So first is the proxy. First is we want to define this frame of this red. Okay, to make it only half of this parent view, and it can take a width and a height. Okay, just get rid of this alignment thing. Right, can take a width and a height. So what about the width? So the proxy return the proxy, we get from this GeometryReader has something called size, which is gonna be the size of your parent view. Okay, and inside this, each size is a CG flow. Sorry, I don't really see the code completion here, but you can see the size is a CG size. Okay, CG size is some sort of structure, contains a width and contains a height. So I can use this height and I'm gonna use this width. And I can take a look at this thing. Actually, it's gonna have this exactly same behavior as before. Okay, now what if I just only want the half of the parent view? Take a look at this thing. Okay, now it only takes half the width and half the height. Okay, but right now it just kind of lives in the corner of this thing. Okay, so we can apply actually another trick here. I apply another frame to expand this thing. Say max width dot infinite and max height dot infinite. Okay, now it can take all the frame offered by its parent view. Okay, so actually there's something quite important thing I don't really have time to cover is the Swift UI layout system. Okay, this is quite complicated thing, and different view have a little bit different behavior. Okay, and this layout system can sometimes offer the space for some children's view, and sometimes the children can ask for some space in need. Okay, so it's really relatively complicated, and this trick we apply here to make the frame, to expand entire space. It's kind of related to the layout system, but we don't really have time, as you may see right now. So it kind of leaves to you guys to actually explore in the area. Okay, but anyway, is that clear how we can use this GeometryReader to achieve something fancier like this? Is that clear? Okay, so what if I change this frame to maybe 100 and 100? You can see again it still takes only half the width and half the height, okay, for the rat inside this child view. Okay, that's how we use GeometryReader. Now let's move to the next topic, which is gonna be, well, pretty interesting demo to show you how to use GeometryReader to achieve something, I mean, pretty decent animation, pretty interesting animation here. Okay, here I have something called test data, which is gonna be have a static let variable. It's an array named as test colors, which contains lots of different colors. Okay, now I have a scroll view, and this time it's gonna be scroll horizontally. Okay, and you can see this is the layout we have right now. So basically you have a horizontal list of different colors. Okay, and you can see the definition of this view here. So take a look at this, and you can pause right here and take a look at this thing. It should be quite straightforward. Okay. Now, let's actually use GeometryReader to achieve some interesting behavior. Actually, let me show you one by one first. First, we're gonna embed this thing to a GeometryReader, and we have a proxy. Okay, here, and we can apply this frame on the GeometryReader. Okay, now you can see we still have the exactly same thing as before. Okay, but now, let me see. Now, I want to apply some rotation effect. You know, so like for all the elements followed by the first one, you have some rotated effect animation. We can apply that. For example, I can apply this dot rotation 3D effect. Okay, it takes two things. I got a little bit messy, but let me try to indent this thing. Okay, so it takes two things. First one is angle, the second one is axis. Okay, for the angle you can go with degrees. Okay, it takes a double. So for example, maybe go with 30 degrees, whatever. Let me actually first show you guys a demo. And for the axis, you can see it takes a tuple which contains 3 elements. All these 3 elements should be CG float. It indicates the axis based on which the rotation should happen. Okay, in this case, I want to base on the y axis, which is going to be the horizontal axis. Sorry, vertical axis. Okay, so I can put 0, 1, and 0. In this case, I means I want to rotate around this y axis. Okay, and you can see I have this rotation right now, right? Maybe I don't want 30, I want negative 30. And you can see this thing, kind of rotated in 3D way. Okay, sounds neat. Seems to be a neat trick, right? So what if I want to, when I actually scroll through this view, it has some nice animation to rotate. So we can use this GeometryReader proxy, okay, to guide this behavior. Okay, so actually let me put this code right here and explain this afterwards. Global dot min max, maybe divide by 10. Now let's take a look at the behavior. Maybe just go with 20. Maybe not. Maybe less. Maybe 7, 6. Okay, here we go. We can see a more prominent behavior here. Maybe go back to 8. Okay, so you can see now we have a nice animation when we scroll this thing. Okay, so let's go back to the code to see how we actually achieve this. So this GeometryReader, this proxy, GeometryReader proxy, can get a the coordination point for some view by using this dot frame. Okay, and this in dot global means I'm gonna get this, the point of something in the global coordinate system, and this min max means this minimum x value for that view. In this case, for example, we just initiate this thing. Okay, this red thing here. Okay, this line, this leftmost line, gonna be the min x. Okay, in the global. Okay, so actually you can see, even if for the first one it has slightly rotation effect, the reason is for the global view it's not 0. Okay, this line, this leftmost edge is not it does not have a 0 for this x axis in the x axis. Okay, because for the global, the 0 happens on the left edge of the iPhone. Okay, so if I go with this left, you can see it gets flat. Okay, we're gonna fix that later. Okay, right now you can take a look at this one to see whether whether this thing actually makes sense. It's a little bit complicated. Okay, it may take some time to wrap your heads around. Okay, now let's see how we can actually solve this thing. What I mentioned before, this thing has a little bit, angle, okay, because it's referring to the global coordinate system. Okay, I want to refer to this coordinate system right to this scroll view. Okay, to this scroll view. Let me see. So first we can have a new thing. Okay, it's add namespace declared with var. It says we can go with whatever name we want, maybe main chord space, something like that. Okay, and you're gonna see how we can use this thing very soon. Okay, so you mark with namespace. Okay, so now let's define a coordinate system on the scroll view. Let's say coordinate space with a name, and this time I'm gonna copy paste this main chord space into this one. Okay, now so the scroll view have a coordinate system named as main chord space or something like that. Okay, it's internally managed. Now for this dot frame, instead of saying dot global, I can say dot named. Okay, and this any hash bar again gonna refer to this value. Okay, now you can take a look at the preview and you can see, let me actually run this thing. You can see it still has a little bit rotation effect on this thing. The reason is I apply a padding on this internal edge stack. Okay, so when we access the main chord system of this scroll view, it still has some kind of offset, so this is not going to be 0. So we can kind of tweak this thing around by only apply padding on this, only apply a vertical padding on this stack. Now we can make this thing actually align correctly. However, I still want this nice horizontal padding, so I can apply this padding here. See padding dot horizontal. Okay, now you can see we got a nice effect here. Meaning there are actually lots of different approach here, and this is just one case or one solution you can adopt. Okay, now let's move to the next or the last topic. Actually, it's called preference key. Okay, so let's take a look at this thing, the skeleton code I have. I have the preference key demo. Okay, and it has a state variable as type name as title, and the default text is hello world. Okay, and inside this thing we have a VStack. The VStack has two things. First is gonna be a text to display the title, and second one is gonna be a text just saying this is main view. Okay, and it has nice blue background. Okay, now we also have a child view, and inside this child view we have a vertical stack. This VStack also contains a text. Okay, let me first comment on this thing and I'm gonna explain this thing very soon. Okay, now what if we have this child view right inside this preference key demo? Now let's take a look at it. Right inside this main view. This is what we got, right? But what if we want to just say dot main view title by doing something like that to change the title from here by applying a view modifier? Okay, does that looks like familiar, right? You guys have been using the navigation title, okay, and this is kind of similar case, and they are actually implemented in some similar way. I'm gonna show you guys very soon. Okay, so how we achieve this. to achieve this thing, we have to, somehow, in certain way, to pass the data from the child view to the parent view. So how we can do that? Okay, we can use something called preference key. Okay, now let's take a look at this code block. Okay, and I have a struct named as title key. You can get whatever you want, and this time it conforms to this preference key protocol. Okay, to conform to the preference key protocol, you have to provide these two things. First one is called default value, gonna be the value you want to pass around. Okay, in this case, I'm gonna pass a string because I want to change the string of the main view, some title of the main view. Okay, the second one is the second thing required is a reduce function. Okay, it's just gonna tell these tell the Swift UI to how to actually calculate the data passed from the child view. Okay, in this case, this value, this in and out value, actually refer to this default value. Okay, so when you change this value, actually essentially changing this thing. Okay, and it also has this next value, but right now the next value actually is a function. It's a function, takes nothing and returns a string. Right now I'm just gonna call this function. It's gonna return something. Okay, we're gonna see some different example later. Okay, now move back to this thing. Okay, so how we can actually pass the data back from the child view to the parent view? We can use something called preference. Okay, and indicate the key. In this case, it's gonna be title key dot self. It's gonna be the type of the key. Okay, and what kind of value I want to pass? I'm gonna say, well, I'm gonna use this thing from child view. Okay, by doing so, you're gonna actually propagate all this data, okay, from this view to all the way to all the parent view. So how we actually receive this data from the parent view? Okay, now let's go back to the parent view. This VStack, I can apply another thing called onPreference change. Okay, it takes two arguments. First one still gonna be the key. You're gonna observe on the title key. Okay, the preference key change on the title key. Okay, so when the title key changes, you're gonna do something. You're gonna perform something. Okay, in this time, I'm gonna name as value, and you can take a look at this. The code completion is a string. So I can just change this title to this new value. Okay, that's how you achieve this behavior by passing data from the child view to the parent view. Let's resume this thing. Okay, you can see the title now is changed based on what value passed from the children view. Okay, now it looks like a little bit ugly. So what I want to do something like main view title. Okay, so how we can do this thing? So we can create an extension on view. Okay, extension on view, and I define a function named as main view title. It takes a value. This time gonna be the string, which is gonna be the title we want to change. Okay, and return some view. In this case, I'm gonna apply preference on self. Okay, gonna be title key dot self, and the value gonna be the value we passed in. Now we have a function named as new main view title on the view, so we can apply this directly. Okay, let's resume this thing. Again, you can see the behavior is exactly the same as before. Okay. Now, what if we have a additional? I'm trying to see this thing. Something goes wrong here. No, everything is right. Okay. So now, what if we have one more view? It's nested view. Okay. Again, I apply another main view title here. Let me actually reorder this thing a little bit. So we have a nested view, and we also want to have this nested view after this thing. Let's resume this thing. Let me take a look. Oh, sorry, I forgot the initializer. Let's take a look at this thing. Now this is nested, right? But there's something that's not what we desired. Now you can see the title changed to this from nested view. Okay, it's not this from child view. Okay, because when this preference, okay, pass some data from the child view, you always prioritize the innermost children view. Okay, in this way you only pass from this data. Okay, you execute this reduce function from the outside to the inside. So you're gonna execute this child view first, then you're gonna execute this nested view. So every time I'm gonna reassign this new value to this value. Okay, and in the end you're gonna be assigned to this from nested view. So what if I want to combine two values from both child view and nested view? Okay, so I can actually do something like plus equal. So I'm gonna append this next value. Okay, something like this. Now you can see we have a behavior we want. It says from child view space from nested view. Okay, actually the preference key can be really handy when it comes to some advanced behavior. For example, you want to count the, let me think about that, maybe count the subviews inside some structure, inside some view, or you may want to, get the frame size of all the subviews or individual subviews. Okay, they can be really handy. And actually that's all for today. And yeah, now let's take a look at all the other things in the Swift UI world, in the Swift development world, and it actually concludes to our, concludes to the end of this quarter. Okay, so as you can see, we touched the surface of the Swift UI, the foundation. Okay, and also there are tons of other things in the iOS world. Okay, for example, core motion. Combined framework is kind of important framework, and this is kind of a cornerstone for the cornerstone for the Swift UI world. Okay, for the Swift UI framework. Okay, and also core haptics, so kind of give you a nice feedback when you touch something on your iPhone. Okay, and like maybe core machine learning essentially can help you to train the machine learning model and apply this one. And if you are a developer for the Apple Watch, you can use the clock kit to develop the to have some nice element for your watch face. Okay, and a lot of things. Okay, so I think that's all for today. And so thank you guys for for being here for the entire quarter, and I hope you guys actually learn some useful things and to actually inspire you guys to explore more on the iOS development. And see you guys